Thanks everyone, and welcome back to the Hyper-V Jumpstart. Again, I'm Jeff Woolsey and this is Simon Perriman. Now we're going to kind of dive in. We're going to go into the Hyper-V infrastructure. And again, just kind of a reminder of where we are throughout the day. This is section 2. I know the first section was a lot of level setting. I promise we're done with that. We're time to get into understanding the Hyper-V infrastructure, how we deal with a number of things. For example, servers and scale. How are we dealing in terms of software recommendations, environmental requirements, Active Directory, configuration, security, deployment, and planning, and enabling Hyper-V. So it's time to get started. We got a whole bunch of things. And like I mentioned earlier, we could be here the entire day, Simon, and we still won't even scratch the surface of what's new in Hyper-V. So let's get going. So when it comes to server and scale, I previously mentioned that we've delivered and have been running some of the largest internet properties in the world off Hyper-V. So we've been running, for example, Microsoft.com. We've been running technet.microsoft.com. We've been running some of the largest infrastructures out there with Server 2008 and 2008 R2 Hyper-V. Those have been traditional scale-out environments. However, now what we wanted to do was we really wanted to move to scale-up environments as well. So for example, one of the things that we did was in preparation for the development of Server 2012, we actually spent a good year of planning. And we literally went to customers all over the world. Small, medium businesses, large enterprises, financials, governments, militaries, you name it, all shapes and sizes. And one of the things you told us was quite simply, look folks, we want to be able to virtualize everything. Okay? No ifs, ands, or buts. We really want to be able to virtualize everything. And so when it comes to the hardware itself, let's talk about some of the hardware we need to do to make virtualization work. Okay, very simply, number one, it's got to be an x64. Folks, 32-bit, that was fantastic in the 90s and in the early aughts. It's a 64-bit world, and Hyper-V is 64-bit. Obviously, multi-socket, multi-core. The more cores you give us, the more logical processors you give us, the larger VMs we can create, et cetera, et cetera, et cetera. In the industry, the most popular server has always been really the 2-socket server. Certainly 4 and higher Hyper-V will take full advantage of, but 2 sockets with many cores and symmetric multi-threading, Hyper-V will take full advantage of. When it comes to virtualization, let's talk about what's required in terms of the actual hardware to make virtualization and what Hyper-V's requirements are. First of all, we need hardware-assisted virtualization. Now, the good news is this is actually technology that's been around since 2005, late 2004. It was in even the Pentium 4s. It was called VT. Intel calls it Intel VT, Intel Virtualization Technology. AMD has it. It's called AMD-V. And basically, this is hardware-assisted virtualization. This is some work that we did with the chip vendors to make sure that they provided the proper instructions that we needed to fully virtualize the x86 platform. Prior to that, there was some heavy lifting that had to be done in software. By moving that into the processor allowed us to do shunt a lot of that work there and get improved performance. In addition, we also require hardware-enabled data execution prevention. This is, again, a core requirement. On AMD, it's called NX, or the no execute bit. On Intel, it's called XD, or execute disable. But basically, this is a security capability. This is a core security feature that we've taken advantage of for many, many releases in Windows, and we continue to take advantage of that in Server 2012. In fact, we absolutely require it. If you try and boot a machine without execute disable or NX enabled, the hypervisor won't even start. We will provide you an error and say, look, make sure this is enabled. The good news is this has been enabled for a very, very long time. So these first two, real simple. Your machines have got that. In fact, my laptops, I've got 5-year-old laptops that have these capabilities already built into it. The next one is second-level address translation. Now, technically, from a server standpoint, this isn't required. If you want to run Windows Server and you want to run Hyper-V, it's not required to use second-level address translation SLAT. However, I'm going to tell you right now, it's highly, highly recommended. And quite honestly, I wouldn't even bother deploying it on a system that doesn't have second-level address translation. This is a feature that's been in the market for already many, many years. This has been at least 3.5 years. One of my old laptops that I use for demoing Hyper-V is a 3-plus-year-old laptop that has second-level address translation. On AMD, it's been called a couple of different things, either nested page tables or rapid virtualization indexing. On Intel, it's called extended page tables or EPT. Again, if you buy a processor processor today, a server processor today, it's going to be in there. And in fact, almost if you buy out pretty much almost any desktop, it's in there as well. On Intel side, it became available in the Core I processor, so i3, i5, i7, and so they're on their multiple generations of those in extended page tables. So second level address translation in there. The reason why we highly recommend it is performance optimizations. So we initially did some work with the processor vendors to make hardware-assisted virtualization, to take advantage of data execution prevention, to make sure we're having the processor and the actual processor providing us a good environment, so we didn't have to do a bunch of software assists to make virtualization work. We then went back to and said, look, we've made it work. Now let's make it really, really fast. And there's a bunch of things that we would have to do in software, such as mapping and managing all of the different address spaces between the different virtual machines running in a virtualized world. Well, second level address translation, we're able to shunt a bunch of that work down to the hardware, and it manages as we map and unmap memory between different virtual machines. So highly, highly recommended. I do want to point out, if you're running Hyper-V on client, SLAT is actually a requirement. In that case, it's not a recommendation, it's actually a requirement. So if you're running Windows 8, you're running Pro or Enterprise, and you want to take advantage of Hyper-V, Hyper-V is built into Windows 8. In fact, it is Hyper-V. It's really, really awesome. So for our developers and IT pros out here that want to develop virtual machines, develop PowerShell automation, do some really advanced capabilities, here's the thing you need to understand. Anything you create on client is fully compatible with server. So we've made it really easy for our developers and IT pros to develop virtualization solutions on their laptops or tablets, Surface Pro, anyone, and deploy it on their server. But I do want to point out that SLAT is required on client. That's a whole other topic, but it's real simple. There's some interaction between high-speed video cards and drivers, and we need SLAT to help us out with that. Local storage. So when it comes to storage, I'm going to go very much into storage later, but when it comes to the local storage, we're actually running the boot OS, the server OS. Certainly, if this is a production environment, you're obviously going to want redundancy. Okay, whether it's RAID 1 or RAID 10, but you're going to want some redundancy in case there's some sort of disk outage on the local machine. 40 gigs minimum, and we are very conservative. We could actually be lower, but we're actually very conservative. We want to think about, patching and futures and things like that. So we keep a fairly healthy minimum there. The good news is storage is incredibly cheap. Even SSDs now, we're talking high-speed SSDs now for sub $100 now. When it comes to memory, it's really, what is your requirement? Is this going to be a server that runs a couple VMs? Is this going to run a couple dozen VMs? This is going to run a couple hundred VMs. From a minimum standpoint, we got to have 2 gigabytes of memory for Hyper-V, but really then it really is how many VMs you want to run. Are you going to be running 4 1 gigabyte VMs? Are you going to be running 16 4 gigabyte VMs? Okay, so really you have to figure out what your requirements are and what is really the goals that you're going after. So really that's the minimum, but the more memory, the more VMs.
Now, how many VMs can you run on a single host in Windows Server 2012?
We actually support up to 1,024 virtual machines per server.
That's pretty impressive. So
and if this is a fully tested, fully qualified, fully validated solution.
So you're saying with 1 gigabyte virtual machines, we can run a terabyte of virtual machines on a single host, essentially. Over a terabyte.
Over a terabyte.
Pretty impressive.
And we actually support up to 4 terabytes of physical memory per server. So
you can run 1,004 gigabyte VMs.
You could really go to town. Now, would I recommend that? Probably not. I really want to understand what your fault domain is, what is this environment. But certainly we have to do absolute boundary testing. We have to run things. We have to run servers as hard as we can, and we absolutely support it all the way up there. So finally, another thing to remember is definitely look for the Windows Server logo. Certified, we have online the Windows Server catalog. On the Windows Server catalog, you'll see hardware, you'll see supported hardware, certified hardware for Windows Server 2012. And you'll see a bunch of folks are constantly updating that. You'll see both hardware as well as software solutions. So for example, if you're looking for a specific server configuration and you want to make sure that you've got drivers, for example, to take advantage of our new virtual fiber channel capabilities, our new SRAOV capabilities, you're going to want to make sure that you see the Server 2012 logo, because if you think you're just going to take something that had Server 2008 drivers and drop it in and expect those to work with 2012 and light up a whole bunch of functionality, that's not going to happen. It needs to have the appropriate driver support there as well. So from a hardware standpoint, actually, it's pretty straightforward. I get a lot of people that wonder, is there anything special I need? Is there any special hardware? It really is very straightforward. If you buy a server today, even an entry-level 2-socket server, you're going to find it's got these things. Okay, and again, from a storage and memory standpoint, it's really more about what is it you're trying to achieve? What is your goal? Is this look, I'm going to set some machines up in a test lab? Or is this really, hey, this is my production private cloud and I need to be thinking long term. I want to make sure I provide some headroom for additional growth. But just to give you an idea, in my office, I got a bunch of machines running with 8 gigs of memory. Okay, very paltry systems, and they're not servers, they're desktop machines. They're literally desktop machines with a little bit of extra storage in them and literally 8 gigs of memory. So we can run Hyper-V on very lowly hardware and be very successful, and I'll show you some of that coming up.
Now, many of you may have this type of hardware in your environments today and just want to try Hyper-V out. And of course, we have the Hyper-V server, so it's a free download. You probably already have the hardware. You get the free download of Microsoft Hyper-V server. You guys can get up and running today with no additional costs.
Absolutely. So as I mentioned earlier, we've been delivering scale out for a long time, but customers, you very clearly told us you want to run scale up. So let's talk about what that means. We talked to you, and there's a couple of things I want to point out. Number one, scale isn't just more virtual processors. I get this all the time. In Server 2008 and 2008 R2, we had virtual machines that supported up to 4 virtual processors. And people would tell me, well, Jeff, I need 8 or I need 16 or I need more because I need to run this big workload. But honestly, that's not the answer. Okay? The key to scale isn't more virtual processors. Let me give you a really succinct example. I can give you a physical machine with 1,000 cores in it, but if it only has 1 gigabyte of memory, who cares? You're never going to keep those cores busy. If we then drop in a terabyte of memory, but there's still only 1 network adapter or 1 disk in the machine, again, it's completely irrelevant. The key to scale is balance. It's about making sure you've got the appropriate amount of resources across the entire system so that you can scale appropriately. In addition, one thing you told us very clearly is live migration should just work. This is something we heard time and time again. I would talk with customers and say, look, I've got a brand new feature. Here's feature X. Okay? I'm going to give you feature X. Feature X is really super cool. But if I give you feature X, this VM is hardwired to this machine. I can't live migrate it. I can't fail it over. I can't storage migrate it. I can't cluster it. It is literally locked to this piece of hardware. How do you feel about feature X? And the answer was always the same. We want you to shoot feature X and we want you to bury out back and we never want to talk about it again. Okay? Because live migration is critical. We want it for planned downtime. We want it for unplanned downtime. No trade-offs.
Now, real quick, Jeff, what is live migration?
Live migration gives us the ability to live migrate virtual machines from one server to another without any downtime. I can have a client attached to a server. I can be doing file server. I can be remoting into it. I can be pinging it. And I can live migrate it from one server to another without any sort of downtime. And this is a key capability simply built into Hyper-V and has been for a couple releases now.
So this would be equivalent to a VMware vMotion or ZenMotion.
And then some. And we'll talk about that. And we'll talk about that shortly. Another thing is performance must increase with cores. So this sounds almost silly that you read this. I mean, if I've got, for example, 2 cores and I give it a workload 4 cores and 8 cores, you expect it's just going to scale and it's going to scale well. But just by providing a virtual machine more virtual processors doesn't guarantee that will happen. There's actually a bunch of hard engineering challenges you need to solve within the virtual machine. I'm about to get to that. Finally, we want to virtualize those workloads considered non-virtualizable. Very often you told us, look, I've done my file, I've done my print, I've done my web servers, but I've got this big mission-critical SQL server over here in the corner. I want to be able to virtualize this thing. This requires dozens of cores, hundreds of gigabytes of memory. It's attached to my SAN through Fiber Channel. I'm using multiple 10 gig NICs for LBFO, and I need to make sure that if I'm going to virtualize that, I need to be able to meet all of those requirements. So those are the workloads we went after in Server 2012. So let's talk about the work that we did to enable these scale-up workloads. Number one, let's talk about NUMA real quickly. So NUMA is a technology that's been around actually for very many years now. Around the end of the 90s, beginning in the 2000s, we started moving really to multiprocessor machines. So one of the challenges we had to deal with was for processors and memories. We started adding more processors now. Well, they need to access memory. They also need to access devices on the bus. And what happens is, even just adding a second processor, okay, this is long before we had multi-core processors, even just adding a second processor now, they're trying to access a device simultaneously, or they're trying to access memory simultaneously, which can be a challenge. So one of the things we did was, the industry, we created NUMA, or non-uniform memory access. And the whole goal of NUMA is to group memory and CPU resources together in what we call nodes. And the reason why you want to do this is because as you allocate threads, as you allocate memory resources, you want to do it with best locality. And this gives you the best performance, especially considering the fact that back then you had these front side buses. So if you had to traverse the front side bus, you'd actually get a very significant performance impact. And the fact that you had multiple processors, all vying, contending for these same resources, again, gave us huge performance penalties and issues. So NUMA was designed to help alleviate that and mitigate that. So here's what NUMA looks like in an ideal world. This is an optimal setting. So here you can see I've got a server. It has 4 NUMA nodes. Each NUMA node has 4 processors, and it's got memory. This is what good NUMA looks like. What I mean by that is memory and thread allocations are all occurring within the same NUMA node. You can see NUMA node 1, its processors and memory all exist in the same NUMA node. Same is true for 2, 3, and 4. In addition, you can see that memory is populated in each node. Well, let me show you what bad NUMA looks like, and unfortunately I've seen this a couple of times over the years. So this is a non-optimal configuration. Usually I see this when basically someone decided to buy a big scale-up server and decided to not fully populate it, or kind of try to reduce their costs, and they bought the very minimal amount of memory and said, over time we'll add more memory to it, but they don't understand how to do it, or they do it in the wrong way. So in this case, you can see the system is imbalanced. What we have here is we have memory and allocation and thread allocations are happening across different NUMA nodes. In fact, we're seeing multiple node hops. You can see here that node 2 has an odd number of DIMMs. So if you're using and trying to take advantage of any sort of hardware interleaving, probably not getting that. NUMA node 3 doesn't have enough memory, so it has to leave its node to access additional memory. And NUMA node 4 is the absolute worst case. It has no local memory. So in this case, all memory accesses require it to leave the NUMA node and are taking a NUMA node boundary hop. This is the absolute worst case that you don't want to do this. So this is how NUMA works on physical. So the reason why I'm telling you this is because this is really important as we move to Server 2012 to provide these massive scale-up virtual machines. For us to give you virtual machines that support 4, 8, 12, 16, 32, up to 64 virtual processors, we need to make sure that we take the NUMA capabilities and actually provide that within the virtual machine. So Server 2012 introduces guest NUMA. And what we're doing is we're presenting a NUMA topology within the virtual machine itself. And the reason why we do this is so that the guest operating systems, so when you install an operating system, modern OS will look at hardware and understand what the NUMA topology looks like. It knows, oh, this processor has these banks of memory and this is how much is in it. This processor has this amount of memory and has this, this is which banks are assigned to it. And it knows where memory is and understands that locality. The operating system does it, and then applications are notified so that they can make intelligent NUMA decisions about thread and memory allocation. So we now provide this in the virtual machine itself. So when you install, for example, SQL Server 2012 into Hyper-V on 2012, it knows completely what the topology of the virtual NUMA topology looks like. So what does that NUMA topology look like? Well, what we do is we make sure that the guest NUMA nodes are aligned with the host resources. So the important thing to understand is we've done all the hard work for you. In fact, we want to make sure that you understand guest NUMA is there. All you need to do is assign virtual processors, and we'll take care of the rest for you. And that the guest NUMA nodes are aligned with host resources. This is also policy driven per host, and you can also force the alignment. So what do I mean by forcing the alignment? Well, let me switch on over here to show you really quickly. So I'm going to show you, and I've got a very simple machine set up here. Here I've got a virtual machine.
And so what management interface are we looking at for the people that haven't seen Hyper-V before?
Thank you. Yes, this is the Hyper-V Manager. In fact, this is what's built into Server 2012. This is the included Hyper-V Manager for Server 2012. So I'm going to go ahead and I'm going to right-click on a virtual machine here, click on Settings. And so, for example, here I've got a VM that's got a virtual processor. But let's say I wanted to give it 8 virtual processors. Fantastic. I do that and I click Apply. Well, NUMA topology, you notice, is not here in the main processor panel, but if you click here and go into the processor, you'll see the compatibility option and you'll see the NUMA option. Now, what you'll see here in the NUMA topology is this is what the current configuration is. It's got 8 virtual processors, it's got a NUMA node, and it's got a single socket. This is what the NUMA node looks like within the virtual machine. What if you want to go around and you want to make changes? You want to change the amount of memory in the NUMA topology. You want to change the number of processors in the NUMA topology. You want to go ahead and mess around and make these changes, which is kind of what I've been doing. Well, what we found out when we delivered the Windows Server 2012 beta was people were pretty excited about NUMA and were kind of interested and curious and wanted to know how to play with it. So people came in here and started messing with these buttons and changing all these things and realized, what did I just do? Did I just dork my virtual machine? Am I going to have inconsistent performance? What's going on here? And if you don't know what you're doing, very likely you're going to impact performance in a negative way.
So could people reset this if they mess it up?
That's exactly what we did. We learned from our developer preview, and in fact, we have this nice big use hardware topology button here. So if you go around in here and you mess around with NUMA and you realize, oh, what did I just do? Don't worry. Just go back here, click on the hardware topology button. Think of it as the big easy button, and look at what it just did. It looked now back at the physical hardware of the machine and it said, oh, here's what the optimal setting was. And in fact, this is the optimal setting for the NUMA configuration for this virtual machine. So the reason you may be wondering, why is this even here in the first place? Well, you know what? We understand that for 99.999% of the situations out there, you're actually going to want to leave the default, and you probably are never going to come to the NUMA configuration. And honestly, for most cases, I'm certainly not going to recommend you do anything here. But there's really one case where you may want to consider having a different NUMA topology. If, for example, you need to live migrate virtual machines between hosts that have vastly different NUMA topologies. So for example, you had a virtual machine running on a server that had 1 socket with 8 cores, and you were moving it to a server that had 8 sockets with 1 core, or 4 sockets with 2 cores. Those are vastly different NUMA topologies, and maybe you need to make that adjustment. So we have included these fine-grained, this really expert options here in NUMA, but here's what you need to understand. By default, we do the right thing. We look at the hardware, we determine what the optimal configuration is, and we set it. And even if you go in here and you decide to make those changes, click on Use Hardware Topology, and we'll make sure you get back to a good state. So we'll be back here in just a minute, but that's a little bit on what we're doing in terms of NUMA topology. The reason why this is important, again, is as you deploy those large scale-up applications, and let me be very clear, scale-up applications are everywhere. Give you a great example. Server 2012 IIS. If you're deploying a large scale-up web server, IIS for the first time is NUMA aware. So what this means is IIS rate 8 running on Server 2012 scales just unbelievably when it comes to performance. We rock performance when it's running on Hyper-V, and it's a great situation. So what does this mean in terms of overall scale for both the platform as well as in the virtual machine? Well, from a hardware standpoint, you can see Server 2012, honestly, we're redefining performance at scale throughout the industry. We now support up to 320 logical processors per server. So to put that in perspective, that's a 16-socket server. Each socket has 10 cores, and then you enable symmetric multi-threading. That's how you get to 320 logical processors. We also support up to 4 terabytes of memory per physical server. So if you happen to have one of these beasties out there, guess what? We have got the perfect workload for you. It's Server 2012 Hyper-V. In terms of cluster scale, I'm kind of giving you a peek at the future of what you'll hear later in the Jumpstart, but we now support the largest scale clusters in the industry, up to 64 nodes and 8,000 virtual machines in a cluster. And one question I do get asked all the time is, Jeff, do I have to have 64 nodes to go 8,000 VMs? Actually, you don't. If you really wanted to, we support up to 1,024 VMs per server. So if you wanted to run a 8-node cluster and 8,000 VMs, we'd support that as well. Would I recommend that? No, because you've created a very big fault domain. In fact, the reason why we scale out to 64 nodes is to actually better disperse the load across the cluster. So the important thing to understand is we can give you whatever you're looking for, and we've got the biggest, baddest clusters in the industry. When it comes to virtual processors, we support up to 64 virtual processors per VM. And I want to be very clear about something here. That's in the client. So if you're running Windows 8 and client Hyper-V, you can get 64 virtual processors if you happen to have a machine with 64 virtual processors on your desktop. And also, this is in Windows Server 2012 Standard as well as Data Center Edition. So you don't need to have just the Data Center Edition to get 64 virtual processors. All of these capabilities, all of these scale limits are the same in both Standard and Data Center Edition. When it comes to VM memory, we now support up to a full terabyte of memory per VM. When it comes to live migration, we've made some huge advancements in terms of live migration. In the past, with Server 2008 R2, it was one live migration at a time. With Server 2012, there is no limit. The only limit is how much hardware resources do you want to throw at it. For example, if I'm live migrating between two servers that have a single gigabit NIC, okay, maybe I can do 2, maybe I can do 4 at a time. If I've got teamed gigabit, maybe I can do 8, maybe I can do a little bit more. If I've got 10 gigabit, maybe I can do 10, 15 at a time. If I've got dual teamed 10 gigabit, maybe I could do 40 at a time. If I've got quad teamed, I can do even more. And I'm talking hundreds of live migrations simultaneously. So because we've done this, it helps future-proof your investment. So that's how we've been thinking about scale. So maybe today you're running gigabit NICs, you're running a gigabit infrastructure, but when you take that and you do that 10 gigabit investment, guess what? Hyper-V is ready for you with Server 2012. Live storage migration also has no limits. We'll basically live storage migrate. Basically, you've got to make sure your storage has all the capabilities to do it, but it's all there.
Now, I have a question from the audience here. What's the default number? You know, let's say I just turn on Hyper-V. What was pre-configured for me for the number of live migrations I have?
Great question. In fact, let me show you that. So let's go on over here. I'm going to go back to the Hyper-V Manager. Again, this is just the inbox UI. Let me show you what it is, and let me show you why we chose it. So if you go to here into Hyper-V settings, these are where we have the global settings for Hyper-V itself. By default, we use 2. And the reason why is we are very conservative by nature. That's the kind of folks we are. We assume you've got gigabit Ethernet and you've got a very congested traffic, and we want to make sure that we don't set the bar too high. So by default, we set it to 2 simultaneous live migrations. What's nice is in Server 2012, we also do queued live migrations. So if you decide you actually want to kick off 8 live migrations, it'll do 2 at a time. If I decide to change this value and say, you know what, I don't want to do 2 simultaneous live migrations, I want to do 4 simultaneous live migrations, then it'll kick off 4 at a time and it'll queue any other live migrations behind it. If you got 10 gigabit, and if you've got Team 10 gigabit, I've demoed dual 10 gigabit live migrations. I've done 60, I've done 80. In fact, I've done over 100 live migrations simultaneously. And so in that case, we just add that number. We just make that number much higher. And really what you should think about is this is the number live migrations that can happen simultaneously. And if you choose to live migrate more than this number is, we'll just queue them up. So that's what's there. And like I said, by default, it's 2.
Now, I know we're going to spend a lot more time on live migration later, but just another good question that I saw here. Can we live migrate between an older version to Windows Server 2012? Meaning, can we essentially run an upgrade of our old virtual machines, move them to our newest platform?
Great question. No, today, if you're doing live migration, it's going to be between like versions of Hyper-V. It's going to be between Server 2012 and Server 2012, Server 2008 R2 and Server 2008 R2. All right, let me go back on over here. So, talked a little bit about the importance of NUMA. I've talked about these new massive scale scenarios, both in terms of the hardware as well as in terms of the virtual machine, and I kind of explained the work that we've had to do in terms of NUMA to make it happen. Well, to show you the results of these efforts, for example, here's Windows Server 2008 R2. This is 32 virtual procs. In fact, the reason I chose this is to show you that this doesn't require Server 2012 as the guest. This works on down-level operating systems as well. In fact, it works on, say, CentOS or Red Hat Linux, which is what you see here. There's 32 virtual processors in Red Hat Linux. So, we're providing you great support. It's interoperable. There it is. Finally, here's a virtual machine. This is Server 2008 R2 again, with 64 virtual processors with a terabyte of memory running a massive scale-up SQL Server database. As you can see here, we are pushing this to the very edges, and guess what? It runs like a champ. So this goes back to the work that we've done together, and I'd like to give a huge shout out and thank you to the SQL team. They've been a fantastic partner to work with to make sure that we can deliver them the absolute best performance and scale that they're looking for. And so you'll find that the SQL team will definitely recommend Hyper-V as the virtualization platform of choice. Well, what about third parties? So what about making sure that we've tested and invalidated this outside of Microsoft? In fact, you'll see that ESG Labs just has performed and validated a whole bunch of tests. They actually did a whole bunch of CPU scalability with OLTP workloads, industry standard workloads, and they published this report that you can download. It's Windows Server 2012 with SQL Server 2012. But this goes and shows us exactly what we were shooting for. Because like I mentioned earlier, we want to make sure that as you add more memory, add more CPUs, you want that CPU load, you want that performance to scale linearly as you add. And again, just adding more processors, virtual processors, wouldn't do it. It was making sure that we looked at the entire system in its totality, and again, NUMA was a big part of that. And you can see here that as the OLTP workload and concurrent user accounts remain constant, the number of brokerage transactions per second scaled linearly up to 64 virtual procs. This is what an ideal linear scalability looks like. So we're very proud of this, and I urge you to take a look at this from ESG Labs. Another question I get asked about is when it comes to virtual procs, what if I don't happen to have the same exact servers? Now, generally, in most cases, when people deploy a private cloud, they tend to buy them and buy identical configurations. So if you're going to buy a production workload, generally we see people will say, I'm going to set up by 8 racks, the same exact server, same amount of memory, same exact storage controller, et cetera, attached to my shared storage. But every so often, someone will say, I'm in a test dev environment, or I'm in a small, medium branch office environment, and I cannot necessarily guarantee that the hardware is going to be the same. Or one case that we see is people will set up a cluster in a production environment. Maybe it's an 8-node cluster, and guess what? Now I've had it running for 2 or 3 years, and now I'm going to set up a brand new cluster, and I want to be able to live migrate into that new cluster, but the hardware has changed. Now I have brand new processors, and I need to be able to make sure that I can live migrate and not have any mobility restrictions. So one of the enhancements we have in in Hyper-V is what we call processor compatibility mode. And honestly, it's just a checkbox. But what's great about this is it's a simple way to allow you to live migrate virtual machines across different CPU versions. Now let me be very clear. It's Intel to Intel, it's AMD to AMD. It's not cross-vendor. In fact, you'll never see that. It's not going to happen. I promise you. That's just not going to happen. It's going to be Intel to Intel and AMD to AMD because there are challenges enough making sure that this works in a flexible and across a broad range of server platforms. But with this, it allows us to move virtual machines across different generations of servers. For example, with processor compatibility mode, I'm able to live migrate VMs literally from a Pentium 4 VT system, circa 2005, to a Core 2 Duo, to a Core 2 Quad, all the way to a Core i7 shipping today. And I can do all of this just by enabling a checkbox. So it gives you great flexibility, and what's nice about this is there are no hardware requirements. So you don't need a special BIOS version. You don't need you don't need to do anything in terms of firmware, and it's literally a checkbox. So it's also per VM. So you can be very granular about processor compatibility mode. So next, I want to talk a little bit about memory and dynamic memory. And I get a lot of questions asking, so how do I make sure that if I'm buying a brand new server and I'm loading it up with all bunches of resources, that I'm using my memory most efficiently? And there's a lot of interesting challenges when it comes to memory management. Number one, what you really want to do is you want to make sure that you use your memory most efficiently. Think about this for a second. You bought a server and you put 128 gigabytes of memory in that server, okay? A full 128 gigabytes of memory in that server. Well, why did you do that? You did it because you want to run a whole bunch of VMs, you want to run it as fast as you can, and you really want to make sure that you get the best possible performance. Okay? What you don't want to do is you don't want to actually create any additional issues. You don't want to, for example, create any operational issues. You want it to provide great, consistent performance throughout the entire system, and you want to fully use that 128 gigabytes of memory. So if you bought a system with 128 gigabytes of memory, you really want us to use up to 128 gigabytes of memory so I can fully leverage that. That's the whole premise by which dynamic memory was created. So this is a feature we introduced in Server 2008 R2 SP1, and we've added some additional enhancements in Server 2012. So very quickly, basically with dynamic memory, you have a startup value. That's how much the VM, when it starts up, is allocated. Then there's a maximum amount, so it will grow over time. So what's great about this is capacity planning. Very often someone will tell me, Jeff, I'm going to deploy a print server. How much memory does a print server need? I don't know. Is this running in a branch office? Is this running in a medium environment? Is this running in an enterprise? Is this your corporate print server? That could be anywhere from, a couple gigabytes to tens of gigabytes. I don't know. Well, with maximum memory and dynamic memory, we will automatically right-size based on the actual memory usage of the workload. In addition, we also have to make sure that we may have spiky workloads. So we may have some workloads that all of a sudden, they're using a gigabyte of memory, but all of a sudden they get very bursty. And they need an additional, hey, I need tens of gigabytes, or tens of megabytes, or hundreds of megabytes, or even more. And all of a sudden, maybe I'll give it away quickly. So one of the things you want to do is make sure that you have a buffer in place so that we don't have to go and automatically start scavenging for memory when you need it most. So the concept of a memory buffer is there. And then finally, there's memory weight. So think about this. I may have a variety of different workloads in my environment. I've got a file server, I've got a print server, I've got a domain controller. Well, my domain controller is really important. Okay? I want to make sure that my domain controller is never starved for memory. So you know what? Maybe I give that a higher weight than my print server. If all of a sudden my domain controller needs memory, I'm going to start taking it from my print server. And the way dynamic memory works is quite simply, we pool all of the memory in the system, and then we allocate it to the virtual machines based on demand. And what we're doing here is we're always using all of the memory in the system. So if there's 128 gigs of memory, we're giving it to those virtual machines as it's needed on the fly. And it works really, really well. Because of that, we've been able to dramatically improve density without creating any performance cliffs, without creating any operational issues. If we give you a feature and say, yeah, this may give you some additional density, oh, but by the way, if you happen to use and go over this cliff, all of a sudden your performance is going to start falling over. That's going to generate support tickets and create operational headache. So dynamic memory is all about using your resources most efficiently.
Well, while we're on the question of resources, I have a question coming in here. What is the overhead of running just Hyper-V on a server?
Great question. I hear that question asked quite a bit, and the thing you have to understand is you have to look at each resource. When it comes to CPU is pretty much free at this point. Memory is pretty much nearly free as well. Okay, where the overhead comes in is generally your I/O, and honestly, at this point, it's not even Hyper-V anymore. When people ask me about bottlenecks in the system, CPU hasn't been the bottleneck for a very, very long time. Memory hasn't been the bottleneck for a very long time. 99 times out of 100 is your storage. Very often someone will tell me, here's the scenario here all the time, Simon. Hey, Jeff, I was running this great, awesome SQL server on a physical machine and performance was great. I then virtualized it. Now performance is awful. When are you going to fix this in Hyper-V? Okay, or insert virtualization product here. And really what this is about is, my question is always, tell me about the storage. Well, when I was running it on the physical machine, it was attached to my SAN. Now it's running on my local machine. It's actually running off my laptop. Okay, so we went from multiple disks and a RAID configuration with multiple spindles, multiple controllers, to the slowest possible storage you could possibly have. A 5400 RPM disk spinning in a laptop. So, Hyper-V, the overhead is so minimal now. It's not even, it's single-digit numbers. And in fact, we're going to get into I/O and storage performance in just a second, so I can dive into that a little bit further. Let me get back to dynamic memory here really quickly, so I kind of explain how it works over time. So in this example on the left-hand side, and I kept the numbers really simple, you can see I've got a couple virtual machines here. I've got a finance VM, a sales VM, and an engineering VM, and a service VM. And so what's happening is I'm gonna start them up. So the time is 0. At this point, they're all using a gigabyte of memory because they started. Over time, 15 minutes later, now they're actually using a little bit more memory. Okay, so the finance VM is starting a report. It's using more memory, and engineering is doing an analysis job, which is using more memory. So dynamic memory is actually allocating memory to the virtual machines on the fly as needed. Finally, we're going to start up a fourth VM, the service VM, and now we realize, hey, we need memory for this VM. So dynamic memory looks at available memory in the system, and if there isn't any available, it will start requesting pages back from virtual machines. And what it's doing is it's allocating and reallocating memory to the virtual machines on the fly. What this means is, if you look on the right-hand side, is this machine has 8 gigabytes of memory, but what we're really using is 7.5 of it, or more, is being used by the VMs. What we're doing is we're making sure that we provide you consistent performance by keeping everything in memory using all of the resources available to it. We're not introducing any additional levels of paging, because what happens is when you do that, your performance falls off a cliff. And now you've got operational issues you have to deal with. You've got trouble tickets because people are going, well, hold on here, what's happening? Why is my performance becoming inconsistent? And that's what can happen if you introduce another level of paging. With Server 2012, we've made some additional changes to dynamic memory. So one of the things we added, as we had startup memory before, we now have a minimum amount of memory. And what this means is, generally when an operating system starts, it wants a little bit more memory for boot time activities and bring up of the operating system. So startup memory in this example, you can see is a gigabyte of memory. But what will happen is over time, as the operating system boots up and everything is running and the system goes idle, there's actually a potential that it could actually fall below the startup amount of memory. So the minimum amount of memory allows you to even reduce the pages further, and almost by default, generally what I do is I do exactly this. I set up my startup memory to a gig of memory, or even 2 gigs if it's a larger workload, but I give it a minimum of 512, for example. So I'll find that there's plenty of pages that can be returned to the system, and let dynamic memory do its magic. Let dynamic memory rebalance and resize and right-size your workloads based on the demands of the infrastructure. I should also point out that dynamic memory is hot. So if you want to change and you want to increase the maximum amount of memory, you want to decrease the minimum amount of memory, you can do all of this while the virtual machine is running. So one feature that we've introduced is a feature called smart paging. In fact, you heard me probably just 60 seconds ago say we don't want to introduce second level paging. So what is smart paging? Well, smart paging is really about making sure that there was a corner case out there that we really wanted to make sure we addressed. So let's go back to the example I gave before. So I've got a number of virtual machines that I'm running, and dynamic memory is allocating the virtual machine. Now, dynamic memory is implemented as a driver running inside the virtual machine that communicates with Hyper-V to determine which pages can be added and removed. So when you restart a virtual machine, there's a point where that dynamic memory driver isn't loaded. And what could happen in some corner cases, if the system is really loaded, I mean really loaded, you wanted to, and you tried to restart a virtual machine, you could run into a case where a VM may not start because they're simply not available. So for example, if I had, in this case, I've got the sales VM and the service VM running, and they're both restarted, and the finance and the engineering VM are actually, they want more memory, and they go and grab it. So they grab it and they take it all. Now they've consumed all the memory in the system, just the finance and the engineering. But the sales and service VMs restarted. Well, now there isn't enough memory for them to even start because the dynamic memory driver hasn't loaded yet. So smart paging was introduced to make sure that we can always restart a VM, always. And what the goal here is to ensure that a VM can always restart, so we can always get to the point where the dynamic memory driver can load, and then we can work again with dynamic memory to rebalance memory across the system. Smart paging files are created per VM, so it's very granular. It's only used during VM restart scenarios. So it is not general second level paging. In fact, we very much consistently are going to stay away from that because the performance problems it causes, the operational problems it causes, and it adds additional complexity to our IT pros out there. Smart page files, by the way, are generally a fraction of the size of memory. So just because a VM, for example, may be allocated 6 gigabytes of memory, the page file, the smart paging file, is not going to be 6 gigabytes. It's actually going to be very small just to get the VM booted, to make sure it's actually booted, and then dynamic memory can do its work. So one thing I also want to point out, a question that I've gotten over since we've introduced smart paging is this one. So if I'm using smart paging, are there any recommendations? Do I need SATA? Do I need SAS? Do I need special SSD for Hyper-V smart paging? Are there any special considerations I need to think about from a storage perspective? Actually, no. Dynamic memory has been architected, so in the vast majority of cases, smart paging actually never kicks in. You will almost never see it. We've actually have to run very specific tests to even exercise this because dynamic memory is very intelligent about how it works, and it almost never even needs to kick in. So it's rarely used, and it's only on a temporary basis. So you don't need any special high-end storage. You don't need to do anything special. We'll take advantage of whatever storage is needed. So that's the key for smart paging.
So I got a question here, and we covered this, but I really want to emphasize the point because it's important. So with dynamic memory, does this mean that we can essentially overcommit memory, meaning we can put more VMs with more memory resources than the physical server has memory to allocate?
So let me be very clear about the question. So you've got a machine that has 16 gigabytes of memory. Can I create a VM that has 32 gigabytes of memory? No. Because if you do that, what we'll do is we'll give it the full 16 gigabytes of memory in the system. We're not going to give it more than that. Here's why. The moment you allocate more memory than is physically in the machine, you are now paging. You are now paging to disk. More importantly, you've actually created a second level of paging. There's paging that's going on within the virtual machine, and there's paging that's going on the hypervisor. These two have no knowledge of each other. And so what ends up happening you can get into some very, very bad situations where a guest is paging and the hypervisor is paging, and these are some cases that can result in extremely bad performance. Your performance gets inconsistent, and it's really, really difficult to try and debug, creating operational challenges. So the way we do it is we'll use all of that memory. If the virtual machine needs more memory, if you give it 16 and it still needs, we'll let the guest page. That's the way you want to do it, because the workload inside the virtual machine knows best what it should and shouldn't be paging. It knows what structures are pageable, as opposed to a hypervisor that is literally blindly paging and unpaging structures that it thinks are safe, but cannot guarantee. So that's how dynamic memory works. So I want to be cognizant of time here. When it comes to software infrastructure, so certainly, as I mentioned before, Hyper-V exists as in Server 2012, as well as in our free hypervisor product, Microsoft Hyper-V Server 2012. Other things you need to understand, though, in the environment is Active Directory. If you're using failover clustering, if you're using it in a production environment, you're going to want Active Directory because you need it for authorization, you need it for delegation, you need it for authentication. You need it to ensure you have a secure system end-to-end. Active Directory is the way we do that for identity. DHCP, if you want to use dynamic provisioning, you want to be able to deploy virtual machines and make sure they've got DHCP IP addresses. Obviously, DHCP is something you're going to want to consider. File server. You're going to need a file server for the VMM library server. Certainly can be on block storage as well, but a file server is an easy way to do it as well. Windows Server Update Services, to make sure that you've got an automated way to patch your infrastructure. Server Update Services is there, and as well, Simon Walsh will talk about Configuration Manager and other ways to patch as well with System Center. Choosing a host SKU. So one thing I want to be very clear about is we've made a number of changes when it comes to licensing, and I also want you to understand how Hyper-V is delivered. So we have the free SKU, and we've got the Windows Server 2012 standard and data center. I'll get to the free SKU in just a second. Let me explain server and data center. First of all, you may be wondering, where'd enterprise go? So here's how we used to license Windows Server. Windows Server used to be available in standard, enterprise, and data center. Standard would give you a certain level of scale. It would support up to 4 processors. Enterprise would support up to 8 processors, and Data Center would support up to 64 processors. In terms of memory, Standard would give you 32 gigs of memory. Enterprise would support up to a terabyte of memory, and Data Center as well. Also, if you wanted clustering, you needed to go to Enterprise or higher. Okay, think about that. Now throw it all out the window, because that has completely changed with Server 2012. With Windows Server 2012, Standard and Data Center are exactly the same. Okay, I know. Think about it. Let that sit in for a minute. I know you're not believing me. Let me say it one more time. Server 2012 Standard and Data Center are exactly the same. Same scale. Clustering is there. NLB is there. There are no differences. Okay, I lied. If you go to the About box, one says Standard and one says Data Center. But they are the same product. Hyper-V is there in the same. All of the scale things that I've talked about, live migration, clustering, it's all there in both. Why is this? Very simple. It's all about licensing now to make it really easy. One of the things you told us was, Jeff, if I want to be able to license a server, how do I know which version of Windows Server? Should I do Standard? Should I do Enterprise? Do I want clustering? There was a lot of considerations about it. Now we've made it really simple. Here's the one question you ask yourself. Is this server for virtualization? If this server is for virtualization, you buy Data Center. Data Center gives you unlimited copies of Windows Server. Unlimited copies of Windows Server instances. If this is for a physical workload, so I'm going to run SQL on the physical iron, okay? All right, use Server 2012 Standard. That's it. That's the only question you ask yourself. So there's the big difference. Now, let's get to the Hyper-V server. What is Hyper-V server? Is this some limited, dumbed-down version of Hyper-V? Actually, no. It's the full hypervisor. It's feature-rich. It's got clustering. It's got live migration. It's got software-defined networking. It's got the extensible switch. It's all in there. But it's just the hypervisor. It is completely free. It is 100% free. It is a downloadable product. It does not include any guests. Okay, so if you want to run Windows Server on it, well, you're going to still need to license the virtual machines on there. If you want to run Linux, guess what? Linux runs like a champ on this. You want to run Red Hat, you want to run CentOS, it's there. So I'll talk more about Hyper-V Server later, but at a very high level, those are some of the differences between the three. When it comes to configuration, obviously, group policy, key consideration for centrally managing your policy, for making sure that you define your local admin, your group control, your Windows update, your security settings, a huge one. Configuring firewall rules. It's automatically configured when you enable Hyper-V. We automatically configure the firewall rule. It's also automatically configured when you're adding a host via Virtual Machine Manager. You can also see down here in the gray box in the purple lettering, there's the PowerShell commands for configuring firewall. And super important to Server 2012 is automation and configuration through PowerShell. We'll talk to that a little bit later.
Now, I'm going to spend just a minute covering some of the deployment and planning tools we have. First thing we want to mention is the Microsoft Assessment and Planning Toolkit. And this is a free download. It's known as the Solution Accelerator, which is essentially products that Microsoft builds and releases out of bands, free downloads. And with the map tool, you can actually scan your entire physical environment, get a detailed report as far as what are all the servers and what are the best practices for optimizing them for virtualization. So it looks at the different types of server roles you have and makes recommendations for co-location of specific roles on servers and which of these servers are optimal for virtualization. But of course, it's going to tell us everything could be virtualized, right? But it's a great planning tool and again, a free download that we have. Now, Windows Deployment Services, or WDS, is one of the Windows Server roles. And this is really designed with Hyper-V in mind as we start to think about all of these Hyper-V deployments. So using WDS, you can now easily go and remotely install your operating system, other roles, other properties such as joining domains, adding and removing features and programs in a fully automated fashion. But we can actually take WDS a step further using another solution accelerator called Windows Deployment Toolkit. And Windows Deployment Toolkit essentially gives you a much broader suite of different tools and utilities for deploying inside your virtualized environment, including things such as installing integration components, different types of OS and distributions, your drivers, and a whole variety of other different components. Next solution accelerator that we want to mention is the Virtual Machine Converter, or MVMC. Once again, a free download, and this allows you to move your VMware virtual machines over to Hyper-V. What it will do is it will essentially scan the VMware virtual machine that's stored offline in a library, understand the different configuration settings such as memory, network, these different components, and then remap them to the Hyper-V version of that type of storage or that type of network. After this, we'll then go and do a copy and essentially move the .vmdk file to a VHD file, and you're essentially bringing this VMware virtual machine over to Hyper-V and then adding it to either your virtual machine manager library or to the Hyper-V manager so that you can then start using it as a Windows Server Hyper-V virtual machine.
One thing to note about the virtual machine converters actually can be done online or offline. So the VM can be running. You don't have to take it offline. That's a choice you make when you're using the conversion. The other thing to note about the VM converter is it's very small. It's only a couple megabytes. So it's a very small download. It does its work very quickly and very easily.
And of course, it's free.
And it's free.
Now, one question that we get asked a lot is about servicing our virtual machines. Now, you probably have lots of virtual machines, but the images are stored in a library somewhere. Maybe it's a file share, maybe a virtual machine manager library. And one challenge we had is keeping those virtual machines up to date with security and compliance, specifically making sure they always have the latest and greatest patches. Because let's say you have your virtual machine offline for a month. You then go and deploy a new instance of this service. Well, that may not be secure. So what we need to do, bring it online, we want to patch it, and then we can put it back offline in the library. So the next time you deploy it, we can ensure that it's secured. Now, final one that we're going to mention here is the Security and Compliance Manager. Now, with Security and Compliance Manager, we've essentially created hundreds and hundreds of different baselines for all different types of security and regulatory compliance issues. So, for example, if you're in the credit card industry and you're collecting billing information, you need to follow PCI compliance. Well, what this Solution Accelerator can do is it will go and scan your virtual machines, your physical hosts, looking at all the various registry keys to ensure that you are fully compliant with all of these different guidelines. You essentially say, this is my server on my virtual machine. It needs to follow this, and this compliance regulation, test it, and tell me what I need to do to go ahead and make these changes so I can ensure that my physical or my virtual servers are fully compliant in my operating system.
Awesome. Thanks, Simon. So, enabling Hyper-V. So like I mentioned earlier, one of the things, in fact, I'm going to switch back on over to the demo system. One of the things I mentioned earlier was the fact that, when you deploy Windows Server, the thing you need to understand and think about is it's a blank slate. It doesn't have any roles enabled. It has doesn't have any features enabled. And so what you really need to do is you need to determine what's the role of the server. Is this a domain controller? Is this a file server? Is it a print server? Well, here I am running Windows Server 2012. And if I want to do that, first of all, I'm going to go in here into Add Roles and Features using the brand new, very easy to use Server Manager. And you'll see it's going to say, let's go deploy a role. Click on Next. What's nice about the new Server Manager, it does multi-machine management. So I've got a couple of different machines here, and I could actually manage and create and install roles on a machine remotely. In this case, I'm going to do it on the local one here. And you can see, here are the roles. Now, I've already installed Hyper-V, but you can see without Hyper-V being rolled, there's nothing else installed. There's no domain, there's no file, there's no print, there's no remote access, no IIS, deployment services. That's my decision. So the best practice we tell you is install Hyper-V. That's it. That's the only thing you need to install here. Click on Next. And now it's going to ask you about features. So features are things that support roles. So for example, if I wanted to use BitLocker drive encryption, or if I wanted to take advantage of things extremely important like failover clustering. So for example, I want to add failover clustering because I want to create a cluster, provide highly available virtualization. So all I do is simply walk through this wizard and click install, and it'll do all that work for me. Now I've already installed Hyper-V, so I'm not going to do that right now. We'll come back here in just a minute. But that's really all there is to enabling Hyper-V in terms of Windows Server 2012. It can also be enabled via PowerShell, and it can also be enabled via Virtual Machine Manager. So for example, with Virtual Machine Manager in 2012 SP1, you can do all this deployment all done remotely. Finally, let's get to Microsoft Hyper-V Server. So I know we've gotten a couple questions about it, and I get this question all the time. Jeff, you mentioned this is free. I still don't understand this. I can't believe that Microsoft is giving me something free. It's not a trial version. I don't understand. So explain to me more. So Very simply, Hyper-V Server is enterprise-class Microsoft hypervisor. To be very clear, it is a local command line interface only. Okay, you're looking at the UI for Hyper-V Server. You notice there isn't anything but a command line interface. The whole goal of Hyper-V Server is to configure it, get it on the network, join a domain, and then manage it remotely. And I can manage it remotely from Windows 8 using freely available Hyper-V management tools. I can manage it from Virtual Machine Manager, but that's really the goal. You basically install it, you run it on the machine, and then you manage it remotely. It's a free ISO downloaded from Microsoft.com. It's designed for remote management, and it contains all Hyper-V features. This isn't some feature-limited version. This doesn't have some sort of memory limit or processor limit. Questions I get all the time. So why would you use Hyper-V Server? Well, number one, Linux. Okay, people will say, you know, I bought Server 2012 and I bought Data Center Edition because the reason I bought it is for the unlimited copies of Windows. So I can certainly run Linux on there. I can put Red Hat, CentOS, SUSE, OpenSUSE, put a variety of different Linux distros on Hyper-V and run it as well. But someone will tell me, but Jeff, I bought this machine with Server 2012 for the unlimited copies of Windows. So is there a way I can still run my Linux distributions on top of Hyper-V, manage it with System Center, but not use one of these licensing slots per se? Yes, use Hyper-V Server. Hyper-V Server can be managed by System Center. We actually do in-guest management of Linux distributions, and you can do all of this running from Hyper-V Server. VDI platform as well as for hosters. So there's a bunch of different reasons to use Hyper-V Server. A couple questions I get asked commonly. Is this an eval version? Is there activation? No. And no, there is no eval, there is no activation. Is this supported in production? Absolutely, since day one. We've actually released 3 different versions of Hyper-V. We had Hyper-V Server 2008, 2008 R2, and now 2012. Does Hyper-V Server have reduced limited scale? No. Is System Center required for live migration or live storage migration? Probably the most common question asked. No, you can do all of this using free management tools, using Windows 8 client, using Windows Server, but no, System Center isn't required. It's certainly recommended, especially as you grow in scale, but it's not required. In fact, you can do it all from PowerShell if you wanted. Is clustering included? Yes, for quite a while now. Does it include live migration? Yes, yes, and more yes. How about the new shared nothing live migration? The fact that I can live migrate between servers that don't have any shared storage, which we'll get to in demo a little bit later. Yes, that's included there as well. What about the new extensible switch? Come on. Yeah, that's in there as well. What about replication? What about DR? What about disaster recovery? Certainly you're not including that with the free hypervisor. Yeah, that's there as well. So I hope I've made my point. This is a feature-rich product. It's been out there for a long time. It's customer-driven. We've basically been adding more features, more scale, more availability, more mobility in every release. And I know that a bunch of you know this because we're seeing now, on average, over 15,000 downloads of Microsoft Hyper-V Server per month. It's probably the biggest secret in the industry right now. Hyper-V Server is getting lots of downloads and lots of attention throughout the world. So we're very excited about that. So we're way over time, but a couple of takeaways. I know we talked about scale, we talked about CPU, memory, storage. Virtualization hosts will have different requirements than infrastructure. We talked about some of the hardware requirements when it comes to the processors, the platforms themselves, about the requirements of memory. Consider virtualization rights because, like I said, in the case of data center, it gives you unlimited rights. And honestly, that's what we're seeing. Because we've made it so easy, people go, look, I'm just going to count the number of virtualization hosts and buy data center, and there we go. I've got unlimited copies of Windows. And then, of course, don't forget to use things like the Microsoft Assessment and Planning tool, which can look inside your infrastructure, agentless tools that can look within your infrastructure and give you a list and say, here are the workloads you can be virtualizing right now with Microsoft Private Cloud. So with that, I think we're going to sign off for now, and we'll see you in the next session.
We'll see you shortly.